class, we are now on chapter 11.7. This is Avogadro's law and volume. So previously you had learned about Avogadro's the 6.022 times 10 to the 23. Now we're going to expand on moles and volume. So what happens when the amount of gas changes? So what happens when you add, up until this point, we've kept the moles constant. Now we're going to change that and add moles. Well, as we add moles, what we see is there is an increase in volume. So based on this graph, you can see the number of moles that increases linearly as it, so this is volume, which is liters, and moles is N. You can see it increases linearly as we add more moles to this container. So we are now going to look at volume and moles while keeping the temperature and pressure constant. So the volume of a gas sample increases linearly with the number of moles in the sample, and linearly, which I have a hard time saying, is just a straight line that it's going up. That's all. This relationship was first stated by Avogadro, and it's called Avogadro's law. And we look at this law at constant temperature and pressure. This is a proportionality. This just means that these are directly related, meaning if one goes up, the other goes up. If the other one goes down, the other goes down. And they go exactly in the same. So that's where you see the linearly happen. So here is Avogadro's law and the formula for it. Now let's take a look at what happens with these changes. So we have moles, the initial moles is 1 mole, and we have the volume at 1 liter. But if we double both, we see that now we have 2 moles and we have double the volume. So we doubled this and it ends up with this. So you can see we have more moles now, but we have also expanded the volume that they're in. And we have to, in order to keep the pressure constant, we have to have a movable valve that keeps expanding out, or the pressure will increase. So the volume of a gas and the amount of gas in the moles is directly proportional. This is very easy to understand. Think about blowing into a balloon. You're blowing air molecules into a balloon. The more molecules that you blow, the more that this balloon expands. And it's the same for a tire. When you're adding air to a tire, you're actually adding air, but air is gas molecules. The more molecules that you add, the more pressures build up, because the more molecules, the more they hit the surface of the inside of the tire, and it expands. The pressure keeps that tire as, where you can ride it. And it's the same with the balloon. The more molecules in it, the more the balloon's going to expand. So let's do some problems. A 4.8 liter sample of helium gas contains 0.22 mole of helium. How many additional moles of helium should you add to the sample to obtain a volume of 6.4 liters? Assume constant temperature and pressure. So let's pull out what we know. And sometimes if you don't know what type of problem it is, just pull out the variables so you can see what you have to work with. And that might also help you understand what type of problem you're dealing with, because they won't always say assume temperature and pressure is constant. So we have a volume and we have moles, and you can see the volume is changed. So based on this is Avogadro's, which of course we're covering right now. But if you didn't know that, you've got a volume and moles. Now we're going to have to solve to see how many additional moles of gas were added. So one thing I want to point out with this problem's not as easy as it seems in the beginning, because there's already helium in there. There's existing amount of helium. And what this wants to know is not the final state of the moles, it's how much additional moles on top of this was added. So this question is deceiving at first. So make sure when you read that you understand exactly what's being asked. And I'm introducing this one first because of the fact that it's not asking for the final conditions. It's asking for how many more moles on top of 0.22 were added. So we're going to handle it though in the beginning as we need to find the answer. So we have to find the answer, and then we're going to subtract the 0.22 moles. So we still need to find N2. So we're going to plug this in, and you can see from here. So we have here's Avogadro's law. We set it up. We isolate N2, which is what we need. Plug in everything from our variables, and we end up with 0.29 moles. However, the final answer is not this. We need to know how much. So how many additional moles of helium should you add to the sample to obtain a volume of 6.4 liters? So in this case, It is 0.29 mole minus 0.22 mole, and the answer would be 0.07. I'll be honest, I don't like this problem. This is what they gave. I'll probably avoid doing questions like this because I don't think they're very clear, and I'm not a fan of them. I don't like problems that seem to be tricky when they're first being introduced. So let's do one that seems more straightforward. If 0.75 mole of helium gas occupies a volume of 1.5 liter, what volume will 1.2 moles of helium occupy at the same temperature and pressure? So this one, let's do it straightforward, just the way that we would normally handle them. So we pull out all the variables, and if you look at one variable, you should be able to detect what's happening. So in this case, we can see that the N increased, so that means that the volume's also got to increase. So we plug everything in, and there's our answer, 2.4 liters. And that's it.